All right, with an understanding of the CFA utility function, what I want to do is I want to figure out how to find the coefficient of risk aversion. A. We know how to get the expected return. We know how to get sigma squared, the variance, but we need to figure out how to get a coefficient of risk aversion. And we can do this a number of ways. First, we could survey folks. So suppose we work at a fund. We're managing people's money. And sometimes fund managers will just survey you, right? They'll ask you, what is the level of your risk tolerance? There is a difference between stated preferences and revealed preferences. And therefore, I would argue that surveys don't work very well. For instance, if you asked me 4 weeks ago when the stock market was doing great, we were at all-time highs 5 weeks ago. If you were to ask me 5 weeks ago, what is your risk tolerance? I would say that my risk tolerance is super high, right? I'm not very risk averse. I want to engage in risky activity that's going to lead to extremely high expected returns, right? However, flash forward 4 weeks when the market is falling apart, and all of a sudden, my level of risk aversion has entirely changed given my survey answers. Does that make sense? So I want you to understand that there's a difference between stated preferences and revealed preferences. The stated preferences on a survey are likely very different than what revealed preferences of risk tolerance would be. So what we're going to do here is we're going to look at two different outcomes, two different states of the world, and we're going to use the willingness of one to buy insurance as our measure of risk aversion. If someone is more willing to buy insurance or someone is willing to pay higher for insurance, that should signal something about risk aversion rather than just surveying them. And this might be one of the reasons why you see a whole bunch of investment companies also offering insurance contracts. I don't know if you've seen that in the past. Back in the 2000s, this was a common thing to do where a financial services firm would have an investment arm, they'd also have an insurance arm, and they could maybe infer what type of risk aversion an individual had by looking at their insurance purchases. Okay? So here we have two outcomes. We have the first state, which is this node. This state is not a good state. It happens with a probability P. So there's a probability P that this state occurs, and in this state, we experience some loss. Let's say this is flood insurance for our home. There's a non-zero probability P that our home gets flooded, and in the case that our home gets flooded, we lose 100% of everything. So the return is -1. Assume we don't have any insurance, okay? So we lose everything. To the contrary, there's a node, a state where there's that occurs with probability 1 minus P, where where nothing happens. There's no flood. Therefore, we return 0 based in this two-state world that we live in. We lose nothing, okay? So let's assume that these two states exist. Let's use this information to calculate the expected return and sigma squared, and let's plug it into our CFA utility function to see if we can figure out how to measure the coefficient of risk aversion. All right? Hopefully you understand what we're doing here. So what I'm going to do, I'm going to take the probability P, the probability that a flood occurs, and I'm going to multiply that by the return in that first state of the world, -1, plus the probability that there is no flood, 1 minus P, times the return in that second state, times 0. Okay? So all I'm doing is I'm calculating the expected return, and you can see that if I calculate the expected return, this can be simplified to equaling -P. Okay? I can also calculate the variance, or the sigma squared. I take the probability of the first state, P, the probability P, times the return in that state, -1, minus the expected return, minus a -P means I get a plus P. I'm going to square that difference, plus the probability that the second state occurs, 1 minus P, times the return in that second state, minus the expected return, -P. I minus a -P, I get a plus P, and I'm going to square that. It can be shown that this can be simplified such that the sigma squared is going to equal P times 1 minus P. Okay? So let's go back to our CFA utility function here. I got the CFA utility function. The expected return is equal to, the utility is equal to the expected return minus 1/2 A sigma squared. So watch what I'm going to do. Recall the expected return in this little insurance example is -P. The sigma squared in this insurance example is P times 1 minus P. And so what we have here is a utility function. I'm just going to plug in the expected return and sigma squared here. I'm going to plug in negative p in here for the expected return. I'm going to plug in p times 1 minus p in here for sigma. And then what I'm going to do is I'm going to set that equal to negative v, where negative v is the value that you're paying for the insurance contract. Because it's an outflow to you, you have to pay for the insurance. There's a negative sign in front of that. So you can think of, I'm using the CFA utility function to figure out what the value of the insurance company is. Look, I'm going to multiply both sides by negative 1. So times this by negative 1, times this side by negative 1. Okay. And when I do that, watch what happens. I get another formula, V, which is now positive, is equal to P plus 1/2 A P times 1 minus P. Okay, so I just multiply both sides because what I'm not interested in the loss of insurance. I'm interested in what is that amount that you're willing to pay for insurance. And this is going to help me figure out what this coefficient of risk aversion is. Notice, from this equation, using a CFA utility function, now what I can do is I can just solve for A. Okay, let me solve for A. And when I solve for A, what do I get? I get A is equal to the value, how much the insurance contract costs, minus the probability that there's a flood, times, or divided by 1/2, I'm just doing some algebra here, hopefully you understand, times P times 1 minus P. Okay? So here is the coefficient of risk aversion using the CFA utility function. So I using the probabilities that these things occurs, and these financial services firms will hire actuaries to estimate these probabilities, I can get the measure, a coefficient of risk aversion from this utility function using this information. This should be fairly straightforward. It's important to understand, look here, if I were to take the partial derivative of V with respect to A, right? This is important. So the partial derivative of V with respect to A, you can calculate what that is. It's 0.5 times P times 1 minus P. Probabilities are always non-negative, so there's zero or positive probability. There's a non-zero or a positive probability there's going to be a flood. And if I took the partial derivative of V with respect to A, then I get a positive partial derivative, suggesting that as A goes up, as the coefficient of risk aversion goes up, so does V. You can see that without taking the derivative, right? As A goes up, V is going to go up. All right? Hopefully you see that in equation 4. This suggests that the more risk averse an individual is, the more willing that individual is to pay for insurance. And this is going to give us a measure of the coefficient of risk aversion.